vector valued functions. Okay, so we're going to talk about vector valued functions. All right, let's talk about that. I mean, the title of it. First of all, do we understand what a function is, right? A function has to have an input and an output. Agreed? Now, what do you think is a vector valued function?
2 points, or 1 point if you count from origin.
What do you mean by that? Sorry.
It's like, when you have a three-dimensional function, you
Okay.
have z coordinate, and it's same here, same thing is here. You have z that will show the length of vector and x and y coordinates.
Okay.
Is the multiplication.
Good. So it's really just going to be, I agree with you. So, by the way, we're not going to go in 3 dimensions in this class. We're going to stay 2-dimensionally. But it's just going to be a function. So, for example, I can say the function, and I got to pick some type of variable. I'm not going to use x or y because x and y are typically associated with horizontal and vertical. So I don't want to use that. I'm going to use a different variable. And that function is going to look something like this. What makes that a vector?
The horizontal and the vertical component.
Yeah, you got a horizontal and a vertical component, and you knew it was a vector because of the notation. Let's start out with that. Secondly, then you knew right away that this right here would be the horizontal component, and that this right here would be your vertical component. Now, what makes this a function? Well, how is this different than just a regular vector that I've, like, for example, the one I gave you before we started this part, which was -2, 3. How is this different?
You have a function. X and y by both of these variables.
Exactly. So you're gonna like, instead of having one specific vector, this is a function that can create an infinite amount of vectors. Are you guys with me? Okay. There's a lot you can do with vector value functions, but for this class and this class only, we will focus specifically on motion. We're going to talk about how vector value functions can be used to describe motion. Okay? Now, before we begin the topic of motion, I want to talk about, if you really think this through, if you have a function in x and you have a function in y, what does this remind you of that we've covered in the past? Yeah, and that's why this gets covered around the same time. You're gonna be able to think of these guys as parametric equations, a set of parametric equations. If you can think about it that way, then this vector value functions is really not that difficult. All right. So let's talk about this idea of motion. All right. So first of all, we're gonna talk about position, and if they give you a position function, like in the past, I don't remember what chapter we covered this in the past, but they usually use the letter S, and then this time the position function will look like a vector. You're going to have a horizontal component, and then you'll have a vertical component. Are you guys with me? Okay. If you do not, and listen to me, I am not trying to get rid of the parameter. I am not trying to get out of a vector world. I want to stay as a vector. Okay? So if I want to stay as a vector, and I know the position is this, how would I find the velocity?
The derivative of each x.
Yep. So then the velocity in this case would be x prime, y prime. Are we okay? Now, you guys do realize then that the position is being represented by a vector, which means it has a magnitude and a direction. And the velocity is also being represented by a vector, which means it has a magnitude and a direction, which are things that you've learned in physics. Is that according to what you've learned so far? All right. There's another term that typically gets confused with velocity, which is known as speed. Now, does anyone know what speed is?
Scalar quantity.
It's the scalar quantity of velocity, which means speed does not care about what? Direction. It only cares about magnitude. So, what is the relationship between speed and velocity?
Speed is the absolute value of velocity.
Speed is the absolute value of velocity. Now, what that means as a vector is, if we don't care about the direction, the only thing we care about is the magnitude, and that means that the speed is the magnitude of velocity. So, is the speed going to be a vector when you're done? No, you're expecting it to be a scalar quantity. Well, how do you find the magnitude of a vector?
Square root of a squared plus b squared.
Cool. So in this very particular case, we're going to say that it's the square root of x prime squared plus y prime squared. Is this making sense? Is anybody lost? Perfect. All right. After that, I mean, just since we're talking about the topic, we can talk about acceleration. All right. How do you find acceleration?
Second derivative.
So it's going to be the second derivative of position, right? So I'm going to do x double prime of t, y double prime of t, or you could say that it's the first derivative of velocity. It depends what you're given, right? I mean, we've covered this in the past, so it's just nothing different about that. We're just dealing with the vector, okay? All right. There's two topics that we're really interested on when we're dealing with motion. And one of those topics is displacement, and one of those topics is how much distance you have traveled, okay? So, if you're given velocity, like let's say I tell you the velocity vector is blah, 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 how can you use that to find the displacement?
Area under the curve.
It's going to be area under the curve. So it's got to be some type of interval. And it has to be a definite interval if we're going to find area under the curve. So it has to be from some value to some value. Now this a and b are going to be t values since we're dealing with t. So it's going to be area under the curve of the velocity. Yes? But
yeah.
What do you guys realize about the velocity? Well, the velocity is what?
Derivative of position.
Well, I'm talking about, like, if you look at this, the velocity is a vector, right? So we're going to have to integrate a vector. Yes? Well, that kind of poses a problem because how are you going to integrate a vector?
Maybe you use like a gradient. You integrate on one side. Out of this, you integrate the other side.
What do you mean by one side and then the other side?
Like by x, and all the time you integrate only by y.
Good.
So if you integrate by x, y is a constant, and y then x is a constant.
Good. The only difference that I would say is don't treat the x or the y as a constant. Just integrate each one individually and separately. Because what's going to happen is you're not going to get the displacement of them together. You're going to get the individual displacement in the horizontal direction, and then a displacement in the vertical direction. But together you can use that to find out the new location. Does that make sense? Okay, I'll take that as a yes. All right. The last thing that we're going to be interested in is, okay, not so much the displacement. What if I want to ask you, what is the total distance traveled? Okay, so total distance traveled, how is that different than displacement?
Total distance traveled, displacement, if you go like forward 2 steps and backward 2 steps, you have displacement of 0, but you've total distance traveled like 4.
Good. Very good. Great example, right? Displacement, if I take 2 steps forward and 2 steps back, I didn't move. It's like I had 0 displacement, but distance-wise, I took 4 steps. So how can we use that example to help us figure out the total distance?
You make everything positive.
So we need to make everything positive by making the absolute value of velocity, right? Yes?
Yep.
Which, if you look at the page, it's like actually to find the total distance is to find the integral of what? The speed. Very good. So you're going to take the integral from a to b of the speed, which in this case is x prime squared plus y prime squared dt. All right, any questions about anything that's on the page before we jump into doing some examples?
Mr. Karen, I don't understand the formula for the speed.
You don't understand the formula for the speed? Up here or this?
The square root x prime.
This one?
Yeah, right there come from.
Okay. Well, let's go back to the previous page at the beginning of today. If I gave you a vector, you sketch it out by, in this case you go whatever units, in this case we went 2 left and 3 up. That creates an arrow, and with that arrow you can create a triangle, specifically a right triangle. Yes? And then we call this 2 and this 3. So magnitude, which is what speed is, speed is the magnitude of velocity. What I'm saying is that this right here is the velocity vector. So if I want to find the speed, I want to find out the magnitude of it, which is the length of it. So if I use a Pythagorean theorem, that's like saying 2 squared plus 3 squared, and that gives me root of 13. So why does that formula work is because whatever vector you have in velocity, yes, this is your vector, you're going to have to square this component and then add the square of this component and take the square root of it, because that's going to give you the length of that vector. Now we're not using numbers because we have functions, but once we start doing examples, then all of these functions will become numbers, so you're going to be able to get actual solutions with numbers. For now, it's just kind of like a formula.
Okay, I understand the formula for the speed, but how do we the formula for the velocity with that formula for speed?
So you don't understand the formula for the velocity, is that what you're saying?
Yeah.
Okay. Do you understand what position is?
Yeah.
Okay. Do you understand what velocity is, like topic-wise, not how to find it? Do you understand what a velocity is?
Yeah.
Can you tell me what it is? Because that's going to help.
It's the speed that has direction and magnitude.
Okay, I got you. I mean, it's just that's just a vector. But like, if you were to explain to somebody what velocity is, like a little kid, what would you say? Like, hey, velocity is this.
To a little kid, I would just say it's the speed of an object.
And then if I was a little kid, I would say, well, what's the speed, dude?
Speed?
Yeah.
Speed is the position an object traveled in terms of time.
Perfect. That's where I'm going with this. Position over time, or how fast something is moving, right? So, how do I find that? Well, I have to have a distance and then divide it by time, if you think about it, right? Like if I say, hey, he ran 20 meters in 2 seconds, then what will be the speed? Anybody? If I ran 20 meters in 2 seconds, what's the speed?
10 meters per second.
How did you find that?
I divide my position by my time.
Yeah.
So I did 20 divided by 2.
Cool. Distance over time. All right, so that will be the speed. So what makes it into a velocity? It gives you a direction. Or you have to have a direction, and that's why we have to do with a vector. Now, why is this working? If you have a position, dude, in order for you to figure out the speed or the velocity, you need to know how much you ran, which is known as the change in your position, and then over change in time. Yes?
Yeah.
Okay. Isn't this just finding a slope? Because it's like change in y over change in x. You're with me? And what's the fancy word for slope in calculus? And that's why velocity is the derivative of position. You're with me?
Oh, okay. Yeah.
And then same idea when we find acceleration. We're looking for the change in the velocity over time. So that's why we do x double prime, y double prime. Cool?
Yeah.
All right, sweet. For the rest of class, what we're going to do is we're going to attempt several free response questions from past AP exams. So you're going to be exposed to exactly what this vector things look like on the AP exam. Some of them are easier, some of them are a little tougher. Ask questions as we progress. Cool? So here's our first one. Example number 1. A particle moves along this path at t being greater than 0, given that x of t is equal to negative t to the third power plus 4 times t plus e to the t power minus 5, and y of t is equal to t squared minus t minus 7. Alright, so all you know is this is the position of this particle, and you know it's a vector valued function because it's got vector components. Here's the two functions, and you just know that the time is greater than or equal to 0, which should kind of make sense, right? We shouldn't have negative time. Alright, part A. Find the velocity and acceleration at time equals 1. Alright, doesn't get any easier than that. It's part A of FRQs. We talked about part A are typically the most simple parts of the FRQs on the AP exam. So how am I going to find the velocity?
Take the derivative.
Okay, so first of all, I know that velocity has to be a vector. Let's start out with that, right? So what's the velocity vector for this very specific problem?
Normally from origin, or if you have a starting point.
I got you, but we can put that anywhere. But what is, like, I mean, we have enough information for you guys to tell me exactly what the velocity vector is.
Negative
X
3
prime
t squared
Right, so negative 3t squared, what else?
plus 4. Yeah.
Is that it?
Plus e.
Plus e to the t. Is that it?
Yeah.
I mean, I disagree because it has to be a vector. I mean,
Well, and then
Y2.
and then
comma, cool,
2t.
2t minus 1. Now, why am I telling you this? When you guys are taking your AP exam, if this is a free response, you want to be able to communicate effectively. And this would be the best way to communicate a couple things. Number one, that you understand that this is a vector. And number two, that you understand how to write it as a vector. Cool? Because you should be expecting that your final answer is a vector, right? Because velocity is a vector and so is acceleration. Agreed? Okay. Now, they didn't ask us for the velocity at any point. They asked us for the velocity at 1. So, what's my final answer for this problem?
One plus e comma 1.
1 plus e comma 1. Anyone need help with how we obtain that? Perfect. All right, now I need to figure out what my acceleration vector is. Well, what's my acceleration vector?
Negative 3t plus e to the power t. Or, yeah. Or wait.
Negative 6t, negative 6t.
Yeah, negative 6t plus et, comma 2. So my acceleration at 1 would be what?
6 plus e on the 2.
Cool. And there's that. And there's that. Cool. All right, easy, right? I mean, honestly, just like before, finding accelerations and velocities from position, whether you have a vector or not, those are very simple, right? It's just derivatives. So hopefully, number one, I mean, this wasn't that terrible. You haven't forgotten how to take derivatives. That's really what I'm hoping for at this point, right? And then secondly, I mean, if you're in calculus, plugging in a number and using some arithmetic shouldn't be a problem at this point, okay? All right, part B. We are going to be asking you for the speed. So part B says, what is the speed of the particle at t equals 2? All right, so if I want to find the speed of the particle at time equals 2 or at t equals 2, then I need to find what?
The magnitude of velocity.
9, yeah.
Yeah, so if I want to find the speed, so the speed at 2, that's going to be equal to the magnitude of the velocity at 2. Agreed? Well, the magnitude of the velocity would be what?
Square root of negative, or 1 plus e squared, or wait, what's the, negative 3t squared plus 4 plus e to the power t squared.
Okay, good. So I got to take, well, it depends. The way I wrote it, I'm already going to plug in the 2, so let me know if I lose anyone. So I'm going to say negative 3 times 2 squared plus 4 plus e squared, right? Plus 2 times 2 minus 1 squared. Agreed? Like, algebraically, I mean, that's how I would go about it.
Can we leave the answer like that?
Okay. Yes, so let's talk about that. On the AP exam, first of all, I'm looking at this question, and just by the looks of it, I can see this maybe not needing a calculator, so that would be totally acceptable to leave it if you don't have a calculator. Okay, if you don't have a calculator, that's perfectly fine. If you wanted to go a little further, I mean, honestly, the only thing I would do is maybe clean that up, because this would be what? That would be negative 12 plus 4, so negative 8. So that would be e squared minus 8 squared plus, what do we got over here? 9, right? Agreed? But, I mean, that's as much as I would do without a calculator. If you have a calculator, then the expectation is that you will take the, I don't know, 10 seconds that it takes you to plug that into the calculator. So, I'm going to go ahead and plug this into the calculator. And, wait a second. Yeah. So, if I plug that into the calculator, let's see. Where's my calculator? Oh, here it is. So we got square root of e squared minus 8 squared plus 9. And he gave me approximately 3.062. Remember, on the AP exam, calculator questions, you are to round to 3 decimal spots. Okay? Questions about anything I did here? I know you can really see the calculator screen, but any questions about anything that's on the page?
Can you go back to the formula for speed? Sorry.
Sure.
So it was x prime t squared, not x t squared.
Right, because look, it's the velocity. So instead of memorizing formulas, think about it as, like, think about the concepts. That's why I wrote this down. It's the magnitude of velocity, and that's why I like to write this down. Here's your velocity. That's why I took this right here, I squared it, and I squared it. And that's what I did here. But I wanted the velocity, the speed at 2, so instead of putting in t, I plugged in 2 everywhere there was a t, so that I could get the exact number. Cool?
Yeah.
Perfect. All right. Last part of this FRQ for this one says, can you find the equation of the tangent line at t equals 2? Okay. Well, let's think this through. In order for me to find an equation of a tangent line, this has been a while since you've done this. What do I need?
You need a point.
Okay.
You need like the derivative.
So I need a point, and what else?
The slope.
Slope.
The derivative.
Okay. Well, do I have any of them? Do I have a point or a slope?
No, you don't have a point, but I mean, t equals 2 is a point, I guess.
Okay. We don't have a, but here's the thing, right? In order for you to write a tangent line, shouldn't you be using the variables y and x? Let's start out with that. Because this is the question that I asked you when we started this. Isn't this basically like dealing with parametrics, even though we're a vector? So when you look at C is kind of taking you completely away from the idea of motion. We're not even talking about motion anymore. It's just like, hey, dude, can you find a tangent line here? So tangent lines, we need y and x, which means we're going to have to find dy over dx, which means we need to find a point that is xy, which we don't have. So how am I going to figure out both of these things? Plug it into where?
xt and yt.
Okay, so if I plug in, then I'm going to get x of 2 equals, what do we got? Negative 8 plus 8 plus e squared minus 5, right? You guys have those equations on your paper, right? Which means you get what? E squared minus 5. All right. And then y of 2 would get us what? We got 2 squared, which is 4, minus 2 minus 7, which gives you a
Negative 5.
-5. So the point that we have then is we have the point e squared minus 5, comma, -5. Are we okay? All right. So now what? How do I find dy dx?
Isn't it going to be dy over dt divided by dx over
Very
dt?
good. If we're dealing with, in this case, parametric equations, dy dx is equal to the derivative of y with respect to t divided by the derivative of x with respect to t, because the dt's cancel and it gives you dy dx, right? Now, do we have both of these pieces of information already? Do we know what dy dt is?
Yes.
Yes, we do, which in this case is actually the horizontal component of,
Velocity.
I'm sorry, the vertical component of velocity, I'm sorry. So dy dt would be 2t minus 1, and dx dt would be negative 3t squared plus 4 plus e to the t, all right? So it's with respects to t, which is fine though, right? Because all I got to do is plug in 2. So that gives me what? I give a 3 here. And then on the bottom, what do I get? 2 squared is 4, negative 12 plus 8. Plus 4, is negative 8. So that's going to give me e squared minus 8. So what is your tangent line?
Y plus 5 is equal to 3 divided by e squared minus 8 times x minus e squared plus 5.
Or you can distribute the negative if you want to. You don't have to go any further than that. That's as far as you can take it if you want, and that would get you your full credit. So let's talk about this FRQ before we move on. Part A and B, completely vectors, completely motion, and then part C, it's like they're kind of throwing a curveball your way, and it's like your mind is thinking of vectors, but was part C really anything to do with vectors?
No.
Not
it's
really.
just tangent.
It was just a tangent line, which is something you learned in chapter 3, so long ago. The only difference is that you were dealing with a parametric equation, which was something that you learned, I don't know, a month ago. So free response questions tend to do that. They don't always stick with the same topic throughout the entire question. In this case, you know, this last part combined three things, right? You had to know vectors so that you could get this information for dy dx, but you had to know parametrics, and then you also had to know how to find a tangent line, which was in semester 1. Cool? All right, any questions about this first one that we did? All right, perfect. Let's try another one. Example number 2. All right, so we've got a particle moving along. So a particle moves along xt, yt, for t being greater than or equal to 0, where the following is information they're going to give you. The derivative of x with respect to time is equal to inverse tangent of e to the negative t, and the derivative of y with respect to t is equal to 3t divided by 1 plus 4t to the third power. Alright, so this time, instead of giving you the position, what are they actually giving you?
Slope.
The slope of that, which is really the velocity. They're not telling you that, you're supposed to know that. Yes? Okay. Part A. Again, you can expect this to be easy. Find the speed at t equals 1. So how do I find this speed? Speed of 1 is equal to the what?
The magnitude of velocity.
The magnitude of velocity, and I'm going to go ahead and plug in 1. Alright, so the magnitude of velocity would be the square root of what?
Wouldn't it be the inverse tangent of e to the power negative 1 squared?
Good. So it would be inverse tangent of, in this case, e to the negative 1, and then squared plus
3 times 1 over 1 plus 4 times 1 cubed squared.
So 3/5 square?
Yeah.
Now, I don't think I need to tell you this, but isn't this one obviously going to be calculated? Just look at the numbers, right? Yes? This, I mean, I don't know what this is. Inverse tangent of e to the negative 1, I have no idea what that is. So we're going to use a calculator, so we're going to get an approximation. So inverse tangent of that. So let's go ahead and try this. So I'm going to do the square root of, parentheses, and then we got inverse tangent of e to the negative 1, and then I've got to square that, plus, what was it, 3/5? So 0.6 squared. So I get 0.696. 0.696.
Meters per second.
You do not have to put any units unless there's units in here. There was no units in here given whatsoever, so don't put units. Cool. If you are given some sort of units, then you would utilize them. But nothing on this problem gave us units, so you just omit any type of unit. Because we don't know if this is meters, we don't know if this is seconds, so don't assume. Cool? Good question though. Alright, easy, right? Part A is always pretty easy, guys. Part B. Find the average speed over the interval of 2 to 6. So find the average speed. Okay. Any thoughts? How am I going to find an average speed?
I mean, you're gonna have to find the speed at both of those, at 2 and 6, and then you subtract them and then divide it by 4, correct? Because that's how we find.
Would it be the integral from 2 to 6 divided by 4?
Okay, so those are two thoughts. Why do you say that? All right, so you say I understand. I think I understand why you said to find. You're basically saying to find the speed at 2 and then the speed at 6, right? So basically finding the slope in a way, right? And then you are saying to do an integral. Why are you saying to do an integral?
So we can get the speed at. The way I thought about it was the average speed. So over so the average speed times the time. What am I even saying? Would be the summation of all the speeds from 2 to 6.
Very good.
That's how I was thinking about it.
Very good. Remember, guys, that when you do an average, you have to add up all of the numbers that you're trying to find an average of, and then divide it by however many there were. Now, I know that you're being told from 2 to 6, so this to me is one of those that I like to call bait, where they want to make you do basically just the slope, which is just the final and the initial. But think about it. There's a whole bunch of speeds that happen between 2 and 6, so you have to find a way to add them all and then divide it by however many there were. This is also known as the second fundamental theorem of calculus. Do you guys remember that? Also known as average value. So, how would I go about doing this then?
It'd be 1 over 4 times the integral of 2 to 6.
So 2 to 6. Okay, so by the way, average speed would equal to 1/4 from 2 to 6. The integral of what, though? If I want to find the average speed, then I should be adding what?
Would it not be like the same equation from A?
Yeah, it will. I need to be integrating the speeds, right? I need to be adding the speeds. Now, instead of plugging in 1, though, I need to make sure that I just leave it with respects to t. So it's going to be inverse tangent of e to the negative t squared plus 3t over 1 plus 4t cubed squared dt. Are we okay? Is anybody lost? Okay, so I'm going to say equals, and let's make sure we remember how to do this on the calculator. I'll refresh your memory. So I got 1/4 on the front. How do I get an integral on the calculator?
Alpha window 4.
Alpha window 4. Alright, so I'm going to go from 2 to 6, and then I just got to be careful typing this thing. So I'm going to put parentheses, inverse tangent, e to the negative t. I'm going to use x in this case. And then that's going to be squared plus parentheses. I'm going to put a fraction in there, and I'm going to have 3t over 1 plus 4t to the third power. Close my parentheses, square those parentheses, and then it's going to be with respect to t. So I think I got everything I need in there, and then I'm going to hit enter. And I find out that my average speed is 0.071. So approximately 0.071. Cool. So in here, they're kind of mixing the idea of vectors with an old topic, which was the second fundamental theorem of calculus. Okay. I wouldn't blame you. I think for I don't remember who suggested to do just from 2 to 6. Just remember that when you're dealing with something like this in motion, you have to consider every single instant between 2 and 6. So that should then lead you to the idea of doing an integral problem. Cool. All right. Part C. Find the total distance traveled from 1 to 6. So find the total distance traveled from minute, or I don't know if it's minute, but for t equals 1 to t equals 6. So total distance is equal to what?
Integral of 1 to 6.
1 to 6.
That's like you have to make it. You have to make sure it's like all positive.
Cool. But remember, we talked about this. So if you're not dealing with vectors, then you just do the absolute value. But since you are dealing with vectors, finding the total distance is doing the integral of what?
Integral speed.
The speed.
So it'll already be positive.
So yes. So it'll be basically what we just did above. Agreed? But instead of from 2 to 6, it's from 1 to 6, and it will not have a 1/4 in front. Agreed? Now, I'm going to show you something because I'm lazy. I don't want to rewrite all this, and you don't have to either. You could just say the following. And that is perfectly acceptable to do. If you don't want to rewrite all that. If you want to rewrite it, there's no problem. Okay? You can totally do that on the AP exam. Now, I'm also very lazy, so all I'm going to do is I'm going to just come up here. I'm going to highlight that. And all I need to change is just, instead from 2 to 6, I'm going to do what?
1 to 6.
1 to 6.
Take out the.
Oh, I forgot, and I already hit enter. Well, let's say I forgot, so what do I got to do to fix it?
Multiply by 4.
So times 4. Cool. So 0.69. There we go.
Mr. Carrion,
Yep.
the reason why that was automatically a positive number was because that's the formula for speed.
Well, yes, and even beyond that, think about this. When you square a number, and then you square a number, whether they're positive or negative, they're going to be positive. So once you add two positive numbers, it's still positive.
Right, okay.
Yep. Cool. All right. Last part for this question would be part D, which is actually pretty easy. I don't know why this is a part D. Find the acceleration at t equals 1. All right, that's not that bad. So if I want to find the acceleration, what do I need to do?
And the second derivative of position.
Find the second derivative of position, but I actually don't have position. What do I have?
Your
First derivative of velocity.
So all I got to do is take the derivative of velocity. Yes? So would you say then that the acceleration would be equal to v prime, oh, I'm sorry, because I don't have b, I don't have a, so at, they do have it in terms of dx dt, so I'm just going to say, I can actually say x double prime, right, and y double prime, yes? Is that fair to say? So how do I do this? You tell me. What do I need to do?
Just find the derivative of inverse tan e to the negative t.
Okay.
And the derivative of 3t over.
All right. So tell me what that is, guys. What is the derivative of inverse tangent e to the negative t?
Be du over 1 plus u squared, but
Yeah.
we have to find what u is.
Well, what is u?
E to the negative t.
So it's going to be e to the negative t squared on the bottom, and what goes on the top?
Negative e to the negative t.
Cool. If you forgot, the derivative of an inverse tangent of u is equal to u prime over 1 plus u squared. So in this case, your u was e to the negative t, as you can see, so we squared it, and then the derivative of e to the negative t is negative e to the negative t. Cool. What about the y component?
I guess we have to use the quotient rule.
Yep. I mean, I really can't think of an other or a faster way. So quotient rule for this one would be 1 plus 4t cubed multiplied by what?
By 3.
3, and then minus 3t multiplied by what?
12t squared.
12t squared, all divided by what?
1 plus 4t cubed squared.
Okay. And then that would be your acceleration vector, right? Should you clean that up?
There's really no need to
No, because they're not asking you to find the acceleration vector for all of them. They're asking you to find the acceleration where?
At t equals 1.
At t equals 1. So the acceleration vector would be what? Negative e to the negative 1 over what? One plus e to the negative 2. Yes? Alright. This one gets ugly, but we'll manage. Alright, so we plug in 1. So that gives you 4, that gives you 5. 5 times 3 is 15, right? That gives you 3, that gives you 12. So 12 times 3 is 36. That gives you 5. 5 squared is 25. Can you leave it like that? Yes,
Yeah, you can.
for sure. Okay. But here's my question. I was kind of waiting for somebody to say something, but nobody did. I mean, this one has obviously been a calculator question, right? Why did you guys do this by hand? All of this. The reason why I bring this up is, okay, was it difficult to do by hand? No. But if you have a calculator, couldn't we have done this in the calculator? Like all of this? And if you don't know, speak up now so I can show you how to do it. Do we not know how to do this?
Could you show us?
Okay, perfect. Your calculator can also take derivatives, guys, not just integrate. It can take derivatives at a specific location, and that's what we're doing, right? We took a derivative, but then we put a 1 in. So that's what we're going to do. If you do alpha window, your option number 3 is a derivative. So all you're going to do is, I obviously don't have t, so I'm just going to, we do have t, but I'm not going to spend my time switching modes. I'm going to stay with x. And then I got to take the derivative of this thing, right? Which was, where is it at? Sorry. I got to take the derivative of these two functions, the inverse tangent and that one, right? So right now I'm going to do the inverse tangent. So I'm going to do inverse tangent of e to the negative t, right? And that's it, right? Where do I want to evaluate it? That's where you have this little blinking line. So it says, where do you want to evaluate it? Well, I want to evaluate it at 1. So I'm going to hit enter. And that's it. So that means as long, here's a key though. If you're going to use a calculator, you need to write at least this statement down so that you understand, or that you show the grader that you understand how to find acceleration. And then when you do ace of 1, all you got to do, you don't have to show any here. Ace of 1 would be equal to, in this case, for the x component, we got negative 0.324.
Mr. Grant, if you keep it in degrees or radians, does it matter, or?
It does matter when you're dealing with trig, which in this case we are. So you should always have your calculator in radian mode when you are dealing with trigonometry.
Okay, so if I put, the degree version of this, then it would be kind of wrong.
Right, you're going to get a different value, absolutely, yeah. Cool. Now I'm going to do the same thing, but now for the y component. So option 3, I'm going to use x instead of t. So what did we have for that one? We had 3t over 1 plus 4t to the third power, right? Yeah. And then same thing, I want to evaluate it at 1. So that gives me a negative 0.840. The other thing important for you to recognize is that this is a vector, right? You should put this in vector form. They expect you to know that. Alrighty. Any questions on anything we've done today?
Can you go back to the page where you talked about finding the equation of a tangent line real quick?
For sure. Let me see, I'm kind of, so this was this part right there. And then that's together.
Can I take a picture of that real quick?
Yeah, take your time. Any other questions, guys? Yeah, I'm recording this video. I don't know how good it's gonna be. Last time I recorded while using Zoom, it was super choppy. So, I mean, I'll upload whatever, however quality came up, but I will for sure upload like a copy of my notes, like the actual written notes. Yeah, no problem. All right, I'm gonna go ahead and stop this recording.